in the last part of the video we have found that when n simple harmonic oscillation of successive phase differences superimpose, then their resultant oscillations become xt is equal to a naught sine n phi naught divided by 2 into sine phi naught over 2 into cos omega naught into t plus n minus 1 into phi naught divided by 2. Now, if we compare it with a ordinary equation of a simple harmonic oscillation of the form xt is equal to a cos omega naught into t plus phi, we can see that the amplitude of the resultant oscillation a is equal to a naught sine phi naught over 2 into sine n phi naught over 2, okay, and their phase factor becomes phi is equal to n minus 1 into phi naught divided by 2. Okay, now what we are going to do, we are going to basically see the behavior of the amplitude as a function of phase differences between the successive frequency, because a is now a function of the phase differences between the successive simple harmonic oscillation. We don't have to really worry about this factor, cosine factor, because it only give the oscillation, periodic oscillation, so it will be always there, so we don't have to really worry about the factor, but we are going to see the behavior of the amplitude as a function of phase differences between the successive frequencies, okay, or successive oscillation. Now let us consider the case when n very greater than 1, that is n is a large number of simple harmonic oscillation superimposes, n is very large, okay. In that case phi almost equal to n minus 1 almost equal to n, so therefore we can write n into phi naught over 2, because n minus 1 almost equal to n when n is very greater than 1, or n is a very large number, so we can write it like that, okay. So phi is equal to n phi naught over 2, okay. So phi naught we can write phi naught will be equal to 2 phi divided by n, okay. So sine phi naught divided by 2 can be written as now sine phi naught, we will write 2 phi divided by 2 into n, 2 to cancel out, sine phi over n, okay. Now you see n is a very large quantity, so this n is very large, the denominator is large, therefore phi by n sine phi by n almost equal to phi by n, because when theta is very less than 1, we know sine theta almost equal to theta. Here n is n is a very large number, so phi by n will be very small, so this condition will satisfy, therefore we can write this thing as equal to phi over n. So what finally we have got, sine phi naught over 2 is equal to phi divided by n, this thing we have got, okay. Now we are going to put this value here, okay, and also we can write sine n phi naught divided by 2, we can write what, sine phi, because n phi naught divided by 2 almost equal to phi, therefore sine n phi naught divided by 2 will be equal to sine phi, okay. So we can put these two things, say this is a, this is b, we can substitute the value of sine phi naught by 2 and sine n phi naught by 2 in amplitude equation. You can see these two value we are basically going to put here, okay. So amplitude a will become a naught, okay, sine phi naught divided by 2, what we have got, phi by n, okay. And what is the value of phi? Phi is nothing but n minus 1 phi naught over 2, okay. and sine n phi naught divided by 2 sine phi. Okay, so here how much we will get? N into a naught into sine phi over phi. Okay, a naught is the amplitude of each harmonic oscillation or each simple harmonic motion, and therefore the total amplitude is equal to n into a naught sine phi over phi. Okay, if this